There are hundreds of different types of cycles both on our planet and in the universe. Cycles also play a key role in both the short-term weather and the long-term climate of Earth. A century ago, scientist Milutin Milankovitch hypothesized that long-term collective effects of changes in Earth's position relative to the Sun are a strong driver of Earth's long-term climate, responsible for the beginning and end of ice ages. Milankovitch cycles include changes in Earth's orbit known as eccentricity, the tilt of Earth's axis relative to its orbital plane, known as obliquity, and the direction Earth's axis points, known as precession. Eccentricity measures how far Earth's orbit deviates from a perfect circle. These variations affect the distance between Earth and the Sun. Eccentricity is the reason why the seasons have slightly different lengths. Currently, summers in the Northern Hemisphere are about 4.5 days longer than winters and about 3 days longer than autumns. As eccentricity decreases, the length of the seasons slowly equalizes. Today, Earth receives about 6.8% more solar radiation in January than in July. Currently, Earth's eccentricity is near its minimum, its most circular point, and it's decreasing very slowly on a cycle of about 100,000 years. Obliquity refers to the tilt of Earth's rotational axis, which is the reason we have seasons. Over the past million years, Earth's tilt has varied between 22.1 and 24.5 degrees. The greater the tilt, the more extreme our seasons become. Right now, Earth's axis is tilted at 23.4 degrees, about halfway between its extremes, and this tilt is slowly decreasing on a cycle of roughly 40,000 years. Precession is like the wobble of a spinning top. Earth's axis slowly wobbles over time. This is due to the gravitational pull of the Sun and Moon, which causes Earth to bulge at the equator and affects its rotation.
In about 13,000 years, axial precession will reverse the seasonal conditions. The Northern Hemisphere will receive more solar radiation, and the Southern Hemisphere will undergo seasonal changes similar to those currently experienced in the North. Additionally, Earth's entire orbital plane wobbles irregularly, mainly due to gravitational interactions with Jupiter and Saturn. Axial precession has a cycle of about 112,000 years. Apsidal precession changes the orientation of Earth's elliptical orbit relative to the Sun. These small changes, triggered by orbital variations, affect Earth's climate over long time scales, individually and collectively, leading to larger climate shifts over tens to hundreds of thousands of years. Milankovitch combined these cycles into a comprehensive mathematical model to calculate variations in solar radiation and corresponding surface temperatures at different Earth latitudes. His model was like a kind of climate time machine, able to project climate conditions forward and backward in time. He estimated that ice ages occurred approximately every 41,000 years. Milankovitch published numerous papers on his hypothesis, and although his work wasn't widely recognized during his lifetime, around a decade after his death in 1958, the scientific community began to take his theories seriously. Several projects and studies, including ones using data from cores drilled in Greenland and Antarctica, confirmed the validity of Milankovitch's work and provided strong evidence that Milankovitch cycles extend back hundreds of thousands of years. His work was even endorsed by the U.S. National Academy of Sciences and the National Research Council. Scientific research continues today to better understand the mechanisms that cause changes in Earth's rotation and how Milankovitch cycles uniquely influence climate. This video does not deny the fact that carbon dioxide and methane gases, released in unprecedented levels into the atmosphere since the Industrial Revolution, are causing climate change. Rather, it focuses on one of many factors that affect the climate: Milankovitch cycles. These cycles are important over very long time spans. Considering Earth's age, they have very little effect over short periods such as a century. Research conducted at the poles provides strong evidence that carbon dioxide and other greenhouse gases have a powerful influence on our climate. Serious action must be taken on global warming before it's too late. We've already seen the benefits of international cooperation, like banning chlorofluorocarbons to protect the ozone layer. So why not now, too?